Hello, my name is Principal Singh. I am Professor of Physics. Today we will study the acceleration time graph. This is an acceleration time graph for a particle which is moving along a straight line. How acceleration varies with time is shown in the graph on the board. So let's see what we can find out from this acceleration time graph. First of all, we know that d by dt is equal to a. That is, the instantaneous acceleration is the derivative of the velocity. This implies that dv equal to a dt. If I integrate this from the limit at t1, the velocity is u, and at time t2, the velocity is v. So we will get, on the left side, the integration gives us v minus u equal to integration of a dt from t1 to t2. This tells us the area under acceleration time graph from time t1 to t2. So the area under AT graph gives us the change in velocity. Over here we have a numerical. At t equal to 0, it is given that the velocity is 5 meters per second. That is, the initial velocity is 5 meters per second. We have to find out the velocity at t equal to 4 seconds. And also we have to find out the velocity at t equal to 10 seconds. We have to find this velocity with the help of AT graph for the particle. So let's see how to find it out. In the question, the acceleration at t equal to 10 seconds is not given to us, but we can find it out by the similar triangle theorem. We'll apply the similar triangle theorem in these two triangles, which says that this perpendicular upon this perpendicular equal to this base divided by this base. So 10 by 4, this is 10 and this is 4, equal to y by 2. So we get y equal to 5. So the acceleration at t equal to 10 is minus 5 meter per second square. Now for t equal to 4 seconds, we know that the area under AT graph gives us the change in velocity. Let's say at t equal to 0, the velocity is 5 meters per second, and we have to find out the velocity at t equal to 4. So we will take the area under AT graph from t equal to 0 to t equal to 4, which gives us the change in velocity. So at t equal to 0, the velocity is u. At t equal to 4, we have to find out the velocity. Let's say it is v1. So I have calculated this area. This is a trapezium and this is a rectangle. So it is half sum of parallel sides into distance between them. Half times 6 plus 10. Sum of parallel sides into distance between them is 2, gives me this area. Then I have to add up this area also, and this is a rectangle. So this is 10, this is 2, so 10 times 2. So this area comes out to be 36. So the change in velocity is 36 meter per second. So v1 equal to u plus 36. That is 5 plus 36 is equal to 41 meter per second. So the velocity at t equal to 4 seconds is 41 meter per second. Now I have to calculate the velocity at t equal to 10 seconds also. For that I have to take the area from t equal to 0 to t equal to 10, which gives us the change in velocity from t equal to 0 to t equal to 10. Let's say velocity at t equal to 10 seconds is v2, and the velocity at t equal to 0 is u. So V2 minus U is equal to area under AT graph from 0 to 10. So this area I have found, it is 51, like this way. This is the positive area and this is the negative area. I have calculated by taking this trapezium and this trapezium minus the area of this triangle, because this is the area on the negative side. So on solving, I got this area minus this area is equal to 51. So the change in velocity is 51 meter per second from t equal to 0 to t equal to 10. So v2 minus 5 is equal to 51. We get v2 equal to 56 meter per second. So the velocity at t equal to 10 is 56 meter per second. Over here, we can also find out the average acceleration. We know that the average acceleration is change in velocity divided by time taken. And we know that the change in velocity is area under AT graph. So this is the area under AT graph, and this is the time interval, and this gives us the average value of the acceleration also. Over here, one thing is very important. At t equal to 8, the acceleration is 0. When the acceleration is 0, the velocity is either maximum or minimum. At this moment, at t equal to 8, if we will calculate, the velocity will come out to be maximum. That is, we can find out the area from t equal to 0 to t equal to 8. That is velocity at 8 t equal to 8 second minus velocity at t equal to 0 second. And this gives us the velocity at t equal to 8 second, which is 61 meter per second. And it is the maximum velocity that is attained by the particle during the complete journey from t equal to 0 to t equal to 10 seconds. Today we will discuss a problem in kinematics, a problem which deals with non-uniform motion. Here the particle is moving with the acceleration which is not constant throughout the journey. A car starts from rest with an acceleration of 6 meter per second square, which decreases to 0 linearly. That is, the acceleration is not constant, and it becomes 0 in 10 seconds. After which car continues with the constant speed. We have to find out the time required by the car, for which it travels total 400 meter from the start. So let's see how to proceed this problem. First of all, we will draw the graph of acceleration versus time graph for the first 10 seconds. Initially, the acceleration is 6 meter per second square, and it becomes 0 at t equal to 10 seconds. If we write down the equation, that is the acceleration versus time graph, the equation for the acceleration versus time, so we use the intercept form a upon 6. This is the intercept on the acceleration side, and this is the intercept on the time side. So a by 6 plus t by 1, t by 10 is equal to 1. This is the way how we write down the equation of straight line x upon a plus y upon b equal to 1. A and b are the intercepts. So we get, on solving, the acceleration versus time is a equal to 6 minus 3t by 5. From here, we will find out the instantaneous velocity. That is, we know that the acceleration is dv by dt. So dv by dt equal to 6 minus 3t by 5. Then we will integrate this equation. It is given that at t equal to 0, the particle starts from rest. So at time, the limit of the time is t equal to 0. The limit of the velocity is v equal to 0. Then at time t, let's say the instantaneous velocity is v. on integrating this equation, we get v equal to 60 minus 3t square by 10. We can also find out the velocity at t equal to 10, because after that it continues with the same velocity, which is the velocity at t equal to 10. So the velocity at t equal to 10 will be, if we put t equal to 10 here, 6 into 10 minus 3 into 10 square by 10, that is 30. So ds upon dt, this is the instantaneous velocity, equal to 60 minus 3t square by 10. Again, on integrating this, we will find out the distance travelled by the car in the first 10 seconds, during which it is moving with non-uniform acceleration. So on integrating this and putting the limits, we get the total distance travelled by the particle in the first 10 seconds is 200 meters. Now, after t equal to 10 seconds, it moves with the velocity of 30 meter per second, because after that the acceleration is 0. The velocity does not changes. In further time t naught, it travels a distance, the constant velocity times the time taken. The further time t naught is taken by the car, so it travels a distance of 30 times t naught. The total distance covered by the particle or the car over here is 200, which it has travelled initially, plus the distance in the further time t naught, that is 30 t naught. This is the total distance travelled. According to the question, the total distance travelled is 400 meters from the start. So 200 plus 30 t naught equal to 400. From here we solve that t naught is equal to 20 by 3 seconds. The total time in which it covers 400 meters is the 10 seconds which it has taken initially for the non-uniform acceleration, plus the remaining time of 20 by 3 seconds which it has travelled with the uniform speed. So the total time is 50 by 3 seconds, that is 16.67 seconds. Thank you.